Hello, and welcome to the lab section of this learning path on the JavaScript programming language. JavaScript is a language which is typically associated with HTML and web browsers, since any JavaScript code can be executed by pretty much all of the browsers available today. Throughout this learning path, we will see how JavaScript code can be linked to HTML pages, and our focus, of course, will be on the JavaScript part rather than on HTML. So before we get to writing any code, make sure that you have some workspace directory created on your system. In my case, I have a folder called Workspace, and this is what I have open in my text editor. There are several text editors and IDEs which support JavaScript, and in my case, I happen to be using Sublime Text, though you're free to use any others which you're comfortable with. So let us begin creating our first JavaScript source file. So inside my Workspace directory, I'm now going to create a new folder. So this is called first.js. And with that done, I'll just expand the workspace folder. And then inside the first.js directory, let us create our first source file. So this is in fact going to be an HTML file with some JavaScript embedded within it. So I'm going to call this one firstjs.html. So I'll first just confirm that the file has been created within this directory. And then I'll just go ahead and paste the code for it. As I had mentioned earlier, JavaScript is often associated directly with HTML and web browsers, and the reason for this is that browsers render HTML pages, while JavaScript is capable of interacting with and also manipulating the HTML. In this specific example, we have an HTML page defined by means of various tags, and within that there is the script tag where we have the JavaScript defined which interacts with this HTML page. So most of the contents of this file follow the HTML syntax, including the head element, the title tag, the h1 header, and so on. However, it is within the script tags where the language is quite different, and this is where we have some JavaScript. So how exactly does this JavaScript work with the HTML page? Well, within the JavaScript code, you can reference the HTML page by means of the document object. That is precisely the object we make use of here, and then we invoke its write method in order to specify the contents of that HTML page. In this case, we just write one line of text to the HTML page, which is, "Hello world, this message is from the web page." Also note the fact that the line is terminated by a semicolon. So you'll observe here that we are including the script tags within the head tag of our HTML. HTML allows some flexibility in terms of where exactly we defined the JavaScript associated with the file, and in this case, we have placed it within the head tag. However, it is possible to have multiple JavaScripts defined for a specific HTML file, and we can also define these within the body element. So within the body tag, we once again include the script tag, within which we have some JavaScript code. In this case, we don't write contents to the HTML document, but instead, we output a message to the console of the web browser. This console can be accessed by means of the console object, and in order to write a message to it, we invoke the function console.log. So this is our first HTML file with embedded JavaScript. Just to summarize what we have here, in addition to the regular HTML elements, we have two script tags. The first of these is defined within the head of the HTML document, the second within the body. One of these writes a line of text to the HTML page by invoking document.write. The other prints out a log message in the browser's console by invoking console.log. At this point, it is now time for us to test out what exactly this file will look like when viewed in a browser. So we save down this firstjs.html, and in my case, in order to render it within the browser, I'm going to copy down the path for this file, which is available in Sublime Text by right-clicking and then clicking on Copy File Path. And then I'll switch over to my web browser. So I have opened up a Chrome browser, and then I'm pasting this file URL into the address bar. Since this is an HTML file, it will be rendered by the browser, but we can now take a look at what exactly the effect is of including JavaScript within the HTML. And what we get is a combination of what we define within regular HTML tags and the JavaScript code embedded within the script tags. So the top line here, my first JS program, was defined within an h1 header element, whereas the second line containing the hello world message was added by the JavaScript. So this is an example of how JavaScript and HTML work together. So while we now know what exactly document.write does to an HTML page, let us now take a look at the effect of the console.log invocation. For that, we will need to bring up the browser console, and if you happen to be using Google Chrome, one way to do it is to right-click on a web page and then click Inspect. So this brings up the Chrome browser's developer tools. Within it, there is an elements tag where you can see the entire HTML which has been rendered. But in order to view any messages which have been logged on the console, we head over to the console tab. And when we do that, the output from our console message can be viewed right here. So we now see exactly how JavaScript can be used in order to manipulate HTML and also to log messages to the browser console. So now that we have used a web browser in order to render HTML which has embedded JavaScript, let us consider a few points. We already know that web browsers are capable of rendering HTML, but they are also capable of executing JavaScript code. In the case of the Chrome browser, it uses something known as the V8 engine in order to perform just-in-time compilation of JavaScript code and then executes it. There are similar engines available for other browsers such as Firefox, Safari, and so on. We can now continue exploring the developer tools of the Chrome browser. So switching from the console over to the Elements tab. So we can see the HTML of our page here. Some of these tags, however, like the head and the body, have been shrunk down, but we can expand it and we can view the entire contents here. So within the head tag, we have the meta and title elements. But one piece missing from here is the script tag which we defined within our HTML source, as well as the h1 header which went into our head tag. This is because the browser has automatically moved these elements over to the body, and in fact when we expand that, the h1 element as well as the first script are visible here. In fact, the body now contains both of the script elements, but importantly, the text which was printed out by the first script, that is hello world, this message is from the web page, is now part of this HTML page's body. To view the scripts themselves, we can expand the script tag. So this is our first script. And then moving further down, we can view the contents of our second script as well, which includes the console.log statement. All right. So we now see exactly how our JavaScript manipulated the HTML by adding this one line of text to the body and then also logged a message on the browser's console. We now continue exploring the dev tools for Chrome by heading over to the Sources tab. And within this, we can view the contents of our first js.html file. In fact, when we click on it, we can view the file exactly as it has been defined. So this concludes our first lab on JavaScript. We saw exactly how JavaScript and HTML are related and how we can embed JavaScript code within our HTML file. We also observed how the JavaScript defined within our HTML can be executed by a web browser. In the previous video, we covered a simple Hello World application written in HTML and JavaScript. That program covered two different ways in which message text can be conveyed to the end user. One of these involved altering the HTML of the page, whereas the other involved writing a message to the browser's console. When writing JavaScript code for your web pages, you will often need to test out whether your code changes are indeed working as they're supposed to, in which case you may want to print out some message which is visible in the browser. We will now take a look at some different ways in which JavaScript allows us to perform debugging of this kind. To do this, I have created a new source folder called Different Ways of Displaying Output within my workspace, and inside it is an HTML page of the same name. So let us go ahead and paste the HTML here, and we start off once again with the HTML tag and include a head element, and then immediately start off with the body. There is a header defined within an h2 element, but it is after that where the interesting part of this demo comes in. So we have a paragraph tag, which is currently empty, but you'll notice that we have set the ID attribute for this, which is set to a value of code. Since JavaScript does allow the manipulation of HTML elements, one way to access the element to be manipulated is by means of its ID attribute, which is precisely why we have given this paragraph tag an ID. And in fact, right after that, we open up a script tag where we define exactly how that paragraph tag will be retrieved and edited. So for that, we make use of a function in JavaScript called document.getElementById, whose argument is the identifier for the element we wish to retrieve. Invoking this will return the paragraph tag in the form of a JavaScript object, and we can edit the HTML contents of that object by accessing its inner HTML property. So we edit the inner HTML of the paragraph tag and then set it to a value of hello world. This is from the setting of the inner HTML. And then following that, we close out a script tag. So within the raw HTML definition, the paragraph tag with an ID of code is empty, but by means of JavaScript, we are in fact adding some text within that paragraph. Beyond that, we will add one more paragraph to the body of the HTML page. These are once again defined by means of the p tags. And then beyond that, we will go ahead and add one more script to the body. So by this point, there will be two different paragraph tags within the body of the HTML page. And within this script, we invoke document.write, which will add some more text to the HTML page's body. So this text, hello world, I'm from the first document.write, will be appended to the HTML body. So it will appear right after the two paragraph tags. And then after introducing a couple of line breaks by means of the BR tag. And beyond that, we introduce two HTML button elements. For the first button, when a user clicks on it, it will pop up an alert window. Such a window can be created by invoking window.alert, and the window object is another one available in JavaScript in order to create new windows. In this case, we create an alert window which will contain the text, hello world, I'm from the window alert. So this button includes the text, click me to view a window alert. And the onClick action for this is of course specified by means of the onClick attribute. So note that at this point, all of the elements which we have defined are still being loaded onto the HTML document. This includes the second button which we now come to, whose onClick action is one more document.write, but you'll observe that the text which we attach to this says, click me to clear the existing HTML. This is because once the document has been loaded, when we invoke document.write, it will overwrite the current HTML contents. So while a page is still loading, document.write will append text to the page, whereas once the page has completed loading, document.write will overwrite the contents. So beyond the second button, we have one more script tag where we write a message to the console once more. So these cover many different ways in which data can be conveyed to the user, either by means of adding to the HTML or by writing over to the console or by means of a window alert. Out of all of these, it is the console.log which is least disruptive to the end user, and in fact, we will be using this extensively throughout this learning path. The window.alert is used less for debugging and more in order to interact with the user, whereas editing the inner HTML of an element is used only if you actively wish to manipulate the HTML of your page. Document.write, however, is very rarely used in actual JavaScript programming, though it is useful for us to learn of this when starting off with JavaScript. It's now time for us to test out our code, so we can save down this file, and then in order to render it in a browser, I'll once again copy the file path, bring up the Chrome browser, and then paste this URL in the address bar. And the page has now successfully loaded and contains all of the elements which we defined within our HTML. Beyond the H2 header at the top, we also see the effects of editing the inner HTML of the p tag with the ID of code. Following that, we have our own hard-coded p tag defined in the HTML. And then we see the effect of the first document.write, which appended text to the web page while it was still loading. Then there are these two buttons which have been added to the page. But before we click on them, we can now bring up the Chrome developer tools by right-clicking and then clicking on Inspect. So once again, we have the Elements tab, which contains the entire HTML. But let us first head over to the console in order to view the effects of the console.log statement. So that message does appear within the console. It is now time for us to test out the buttons. So clicking on this first button should bring up the window alert. And that is precisely what happens. So such window alerts are very useful means of communicating some information to the user, such as the successful submission of some data or even the result of some operation which they have invoked. To get rid of this, I'm just going to click on OK. And now we will go ahead and click on the second button. So this will invoke another document.write. But because this web page has already loaded, this invocation of document.write will clear out the entire HTML and replace it with the contents of the second document.write. Since invoking document.write on a fully loaded web page has the effect of rewriting its entire contents, it is very, very rarely used. At this point though, we can recover the original contents by hitting refresh, in which case, all of the original HTML along with the JavaScript is reloaded by the browser. In the examples which we have covered so far, we have embedded our entire JavaScript code within the HTML files. While this is definitely very convenient in order to get started with HTML and JavaScript, it is not good practice to have both within the same source files. From this demo onwards, we will separate all of our JavaScript definitions into separate source files and then simply have links to them within our HTML. One reason for doing this is to separate the visualizations of your web page, which is defined via HTML, from the logic which is used to manipulate and work with the HTML, which is set within the JavaScript. You'll observe on screen that I have created a new folder called separate HTML and JS, and within this, there are two different files, an HTML file and a JavaScript source file with the extension of .js. I now have the HTML file open, and you'll observe that this includes a head tag as well as a body. And within the body, there is a script tag. But rather than having the HTML hard-coded within that, we in fact have a source attribute which points to the location of the JavaScript source file. Since the JS file is available within the same directory, I don't need to lay out the entire path to the file, and I just mention its name, which is separate HTML and JS.js. With this separation, it is possible to have different teams work on the HTML and the JavaScript. The HTML developers can focus on the presentation of your web page, whereas the JavaScript developers can focus on the logic behind those HTML pages. The HTML and JavaScript are linked together by means of this source attribute in the script tag. So with the HTML defined, let us move on to the logic behind this HTML and switch over to the JavaScript source. So this is currently empty, and within this file, I'm simply going to include two different statements, a document.write and a console.log. So you don't need to include any HTML tags within this JavaScript source file, and the developer has the option of working with JavaScript syntax alone. So we can now save down both this JS file as well as the HTML, and in order to view whether the separation of HTML and JavaScript does work as intended, let us bring up this HTML file in the browser. So switching over to the HTML file, I'll just right click and get the path, and then follow it up by pasting this URL in the browser. So what we need to see is whether all of the HTML which we defined in our HTML file is displayed, and whether the document.write and console.log statements from the linked JavaScript is also executed. And all of that happens exactly as we expected it to. The text at the very top, this is from the HTML file, is thanks to the h2 header defined in the HTML file, but the line which comes immediately after that is clearly from the JavaScript file. So the HTML and JavaScript do work together even if their definitions are within separate files. It is now time to test out the effect of the console.log message, for which I will bring up the Chrome developer tools. And if you're on a Mac OS, the keyboard shortcut to bring it up is Command plus Option plus I. And when we do that, the message can clearly be seen within the console as well. We can now switch over to the Elements tab in order to view the document object model, or the DOM, of the HTML page. And when we do that, we can see that the HTML page is rendered as a tree structure, which includes a top-level HTML element, within which there is a head as well as a body element. When a browser such as Chrome renders an HTML page, it first converts it into this document object model, and it is this document which is accessed by JavaScript. So when we invoke document.write from a JavaScript source, we are in fact editing this DOM which is rendered by the browser, and we end up writing text to the body of the DOM. This is why we can see the text, "Hello world," this message is from the JavaScript file, within the body of this document object model. We can also observe within the script tag that the location to the source of the JavaScript file is also available here as defined within our HTML. But the question is, can we view the JavaScript source itself from the Chrome developer tools? Well, if we expand the head element, we can see that it's not embedded within the document object model. However, if we head over to the sources tab, we observe here that there are two different files defined within our directory. So we have the HTML file as well as the JS file. And by clicking on the HTML file, we can view its contents exactly as we had defined it. And then moving along, we can click on the JS source, and this gives us the contents of our JS file as well. So even though we simply opened up an HTML file in the browser, it was smart enough to spot a linked JavaScript source file, and it loaded that into the browser as well. For the remainder of this learning path, we will continue defining HTML and JavaScript within separate files. In the previous demo, I had touched upon the fact that JavaScript is used in order to manipulate the document object model of an HTML file. So we load an HTML file into a browser, which in turn translates it into a document object model. That model in turn can be accessed by means of the document object from a JavaScript source file. And in this demo, we will take a look at how exactly specific elements within the page can be accessed and edited. We will also be introduced to the concepts of variables in JavaScript, and we will play around with a few simple numeric and text variables. Just as in the previous video, we will have separate HTML and JavaScript files. So here I have the HTML file up on screen, which contains the usual head element. But within the body, you will observe that there are two different paragraph elements. The first of this has an ID of numeric section, whereas the other one has the ID of text section. In our JavaScript file, we will be accessing each of these elements by means of their ID and then manipulating its value. So within the HTML file itself, you'll observe that each of these P elements are currently empty. When this file is loaded into a browser, however, it will be translated into a document object model, and then JavaScript steps in to modify that document object model. The JavaScript itself is within the source file accessing dom.js, the link to which is available as the source attribute within the script tag. So we can save down this HTML and then head over to the JavaScript source file itself. So I'll just go ahead and paste the code for it. And right at the top, you can see how exactly we are accessing and then manipulating the DOM. The DOM is available to us in the form of the document object, and we retrieve the first of the paragraph tags, which has an ID of numeric section, by invoking the document object's getElementById method. Specifically, we modify the inner HTML property by setting it a value of 30, and this value will appear within the paragraph tag. We end up doing pretty much the same operation for the next paragraph element, which is accessed by its ID of text section. The contents of this paragraph tag, though, is going to be some text where we just put in the value name John. So with these changes made to the document object model, we can now test out its effects by bringing up the browser and then opening the HTML file there. And we can see exactly how the document object model has been modified by our JavaScript code. It's now time for us to move along to playing with variables in JavaScript. But before we get to that, I'll just bring up the browser console. And I did this by hitting the keyboard shortcut on my Mac, which is Command plus Option plus I. And you'll observe that the console is currently empty. To understand exactly how variables work, we will be modifying their values frequently and then printing out their values to the console in order to view the effects of our code. The use of console.log in order to debug and develop code is a very common practice, since it allows us to get quick feedback on our code changes. So let us head back to our source file and introduce those code changes. The first thing we do is to declare a variable called a. We do this by making use of the keyword var followed by the name of our variable. And you should note that this keyword var simply denotes the fact that a happens to be a variable and does not bind it to a specific type. So a can be either an integer or a string or pretty much anything else at this point. This is because JavaScript is a weakly typed language, which contrasts it from strongly typed languages such as Java and C. So in the next line, we assign a value to this variable a, and we set it an integer value of 10. It is also possible to declare multiple variables within a single line by using the var keyword. So we declare the variables b and c within a single line. And it is also possible for us to initialize the values of multiple variables in one line. So if we want b and c to have the same values, specifically the integer 20, we can simply execute b equals c equals 20. You'll observe that each and every line of code within our file is terminated by a semicolon. So this is a line termination character in JavaScript. And in most cases, it is possible to eliminate the semicolons and still execute the JavaScript. We will discuss that, however, a little later. For now, though, we will focus on variable declarations here. So in addition to a, b, and c, we now introduce one more variable, And this time we declare X without the var keyword before it. This is also something which is possible in JavaScript. We can now set X a value, which is in fact derived from another variable. So it will have a value of A plus 30. So we expect it to be equal to 40. So with a number of different variables declared and initialized, we will print out the 4 different variables and then observe their values. This printing out of values will take place on the browser console, and turning our attention to the first of these console.log messages, you'll observe that we print out a string within double quotes which says value of A followed by a colon, and then we append a value to that string by means of a plus symbol. This symbol is followed by the variable A, which, even though it is an integer, will be translated into a string by the JavaScript engine. So we do pretty much the same operation for all of the other variables as well. And moving along, we will now define one more variable, again without the var keyword before it. And this variable y is also derived from previously declared variables of B and C. Like with most other programming languages, JavaScript uses the asterisk symbol in order to perform a multiplication. So y is going to be the product of B and C. So we'll also print out y to the console. And let us see how exactly all of these variables have been initialized. So we save down our sources, head over to the browser where the HTML page is already loaded. But now that we have some changes, we can hit refresh in order for those changes to take effect. And we observe within the console all of our console.log statements. A, B, and C were set to the values of 10, 20, and 20, and the derived values of X and Y also appear as expected. So now that we have worked with numerical variables, it is now time for us to work with some strings. So heading back to our source, I will now declare 3 different string variables. So all 3 of these variables are called student name, but with slight variations. So the first one has a value of Brianna, but here we have used the upper camel case for the variable name. The second one uses regular camel case, and this is set to a value of John, whereas the third one uses underscore to separate student and name, and this is set to a value of David. JavaScript is a case-sensitive language, which is why each of these 3 variables are in fact separate from each other. And we can confirm that by means of these console.log statements where we will output these variables to the console. All of the strings we have worked with so far in this course have been defined within double quotes, but JavaScript also allows strings to be defined within single quotes and backticks. So you have a single quote string as well as a backtick string here. But you will observe a couple of variations within the strings which we print out in these console.log statements. In the case of the single quote string, we make use of %s, which says that a string needs to be substituted in its place, and the specific string itself is specified after the comma, which is single quote string. This string substitution is also available when using double quotes. Note, however, something which is unique to strings defined within backticks. It is possible for us to evaluate an expression within such strings by defining that expression within parentheses prepended by a $sign. So we can save down this file, and then to view its effects, we head over to the browser and hit refresh. And all of the different strings which we defined are now available in the console. In the previous video on variable declarations in JavaScript, we made use of the var keyword in order to declare some variables, but there were also other variables which we were able to initialize and use without declaring them first. That, plus a few other operations which JavaScript permits, may lead to problems further down the line. And in order to prevent that, JavaScript has introduced something known as strict mode, which we will now take a look at. Once again, I have a new folder containing 2 different files, an HTML and a JavaScript source. So this is the HTML file, but all of the relevant stuff for this demo will take place within the JavaScript source. So switching over to that, I'll just go ahead and paste some code. Here we have one variable a, which is declared using the var keyword, and then another variable b, which is undeclared. We assign the integer values of 10 and 50 to them, and then we print them out to the console. And you'll note here that we make use of %i in order to substitute integers in their place in the string. So the first %i will be substituted with the value of the variable a, and the value of b will take the place of the second %i. By default, JavaScript does not use strict mode. So even though we have an undeclared variable b in this case, once we save down this file and bring up the HTML page in the browser, we should expect that there are no errors and that the variables a and b are printed out to the console. Alright, so the loading of the page took place without any issues. And now we can bring up the console. And you see that the values of a and b are printed out as 10 and 50. So undeclared variables are clearly not a problem for JavaScript by default. However, in many cases, you may consider that this is not good programming practice. And in the case of JavaScript, any undeclared variable effectively has global scope, which means that it won't be possible for you to use the same variable name anywhere else within your code. And this is particularly problematic for large source files. So in order to prevent undeclared variables, JavaScript has something known as strict mode, which is disabled by default, but we can enable it. To do that, all we need to do is to include the string use strict. And if we include this at the top of a JavaScript source file, then strict mode will apply to the entire file. So with strict mode in place, the potentially unsafe operation of using an undeclared variable b is prevented. And developers will need to get into the habit of always declaring their variables before they put it to use. So what is the effect of including this use strict directive within our JavaScript source file? Well, we can save it down and then test it out by heading back to the browser. And this time when we refresh the page, we observe that when the JavaScript is compiled, we get an uncaught reference error. Specifically, the problem is caused by the fact that b is not defined. You'll also observe that the console message tells us that the problem occurs within strictmode.js at line number 4. So we will need to fix it. So we head back to strictmode.js and then over to line number 4, where we add in the var keyword just before the variable name. So both a and b are now declared, and we can confirm whether this works in strict mode. So saving down the file, we head over to the browser and hit refresh. And yes, the print message now appears just as it did before. So the use of strict mode prevents some other operations as well, which could lead to errors further down the line. To demonstrate some examples of that, we head back to our source file, and I'll just turn off strict mode by commenting out this use strict directive. Note that I'm making use of 2 consecutive forward slashes in order to add a comment. And this means that anything beyond these 2 slashes on that line will be disregarded by the compiler. So by turning off strict mode, we will now go ahead and declare 2 other variables. So the first of these is called private, and the second one is called undefined. We will soon see that the keyword undefined has a special meaning in JavaScript. However, by default, the compiler does allow us to use this as the name for a variable. On the other hand, the keyword private is reserved for use in the future. With strict mode turned off, we will observe that it is possible for this JavaScript to be compiled and also executed. Note here that both private and the undefined variables currently have string values. So once we save this down and then head over to the browser and hit refresh, we observe that all of the 3 console.log statements do get executed and there are no errors. So moving to the second variable, we see that the string value of the private variable is printed out. However, in the case of the variable undefined, its value is not a string, but in fact appears as undefined. As I had mentioned, this is something which already has a special meaning in JavaScript, while the private keyword is reserved for future use. So the variable undefined is rather meaningless since we can't really reference it, and the variable private could cause problems further down the road. It is to prevent such issues that we turn on strict mode in our source files. So heading back to strictmode.js, we will just uncomment this line so that strict mode is enabled. And let's take a look at the effects when we head back to the browser and then refresh the page. This time we get an uncaught syntax error. And specifically, in line number 8, we see that there is the unexpected use of a reserved word. And heading back to the source, we see that the problem is the use of the private keyword. So I'm now just going to modify this to private var, which is not a reserved word, and then change the reference to that variable as well in the console.log statement. And then saving this down, let us head back to the browser and refresh. And this time, the first of the console.log statements does in fact execute, but we end up with this uncaught type error in line number 9. And specifically, this is the problem with the undefined variable. So heading back to our source, I'm going to modify this to undefined str using camel case. And let's take a look at the effect by heading back to the browser and then hitting refresh. Now there are no errors in our code anymore, and also the correct value of the undefined var is displayed on the screen. So in this demo, we took a look at just some of the operations which are not permitted when we enable strict mode, and we also turned it on for the entire source file. It is possible in JavaScript to enable strict mode for just specific functions, for example, and there are several other behaviors which are not permitted when running under strict mode. Covering all of those is beyond the scope of this learning path. However, it is useful for you to know that such a mode does exist in the language. In the previous video, we saw that enabling strict mode for a JavaScript source file will prevent the use of undeclared variables. However, all of the variables which we have declared so far have been done using the var keyword. Now, JavaScript is a weakly typed language, which means we don't need to explicitly bind a variable to a specific type, which is why any variables which we have declared using var could be assigned to either integers or strings, and in fact, they can be assigned to any type of variable. So, what exactly is the point of the var keyword then? Well, in this video, we will observe how the use of var in order to declare a variable contrasts with two other keywords, let and const. So once we have defined the HTML for this demo, we will move ahead to the JavaScript. And from now on, I am going to enable strict mode for pretty much all of the remaining demos in this learning path. So let us begin by pasting some code. So first, we declare three different variables using the var keyword. So these are price1, price2, and total. And total is the sum of price1 and price2. So we can print these out to the console as well. And let us view the effects in the browser. So saving down this JS file, I'm going to open up the HTML in the browser. And once the page has loaded, we can bring up the console where we confirm that the value of the total variable is correctly assigned as 15. Now let us head back to the source file, and this time we will reassign the values of price1 and price2 and then recalculate total. So this time the value of total should be 35. Before we head over to the browser, however, observe that I have included two single-line comments within this file. On line number 3 and line number 10, I have made use of the double forward slash followed by some text in order to describe what I'm doing in the following lines. Alright, let us head back to the browser now and ensure that the newly calculated value of total is indeed 35. And upon refreshing the page, that is the confirmation which we get. So we head back to the source file, and you'll observe that all we need to do is to reference a variable in order to update the value, and we don't need to redeclare it. But what if we end up redeclaring a variable using the var keyword? This is something which can happen if the code base is rather large and there are many different variables which are declared, and you don't know which variable name is already in use. So will the compiler prevent this redeclaration? Well, to test it out, we head over to the browser and hit refresh. And the answer is no. So we are able to redeclare variables in JavaScript even in strict mode, at least when we make use of the var keyword for our declaration. Which brings us to another keyword which we can use when declaring variables, which is the let keyword. Here there are two variables, dividend and divisor, which are declared using let, and we should expect that the value which is printed out to the console in this case will be 21. Observe that it is a single forward slash which functions as the division operator in JavaScript. So we save down our file and then refresh the page in the browser, and the division is performed correctly. So far, the let keyword works exactly the same way as the var keyword does. Let us perform another test. Is it possible for us to update variables when they have been originally declared using let? So we update the values of dividend and divisor, and then when we head over to the browser and hit refresh, there is no error which is observed in the console, and in fact, the correct value of 24 is printed out as a division result. Alright, once more, this works exactly the same way as the var keyword, which now brings us to the point where there is a variation in the behavior of variables when declared using let and var. So this time we will try to redeclare the dividend and divisor variables with the let keyword, but on this occasion, the compiler will throw an error. Now observe that between lines 41 and 44, I have once again made use of a comment to describe what exactly takes place in the following lines. However, on this occasion, I have made use of a multi-line comment. In JavaScript, multi-line comments begin with a single forward slash followed by an asterisk and end with an asterisk followed by a forward slash. Those of you who are Java programmers will recognize this immediately, as the same syntax is used for comments in Java as well. Well, coming back to JavaScript and the use of the let keyword, let's see whether redeclaration of let variables are possible. So heading over to the browser and then refreshing, what we end up with is an uncaught syntax error, since the variable dividend has already been declared. This error message, in fact, has been thrown upon encountering the first error in the source code, which is why we don't see the same syntax error for the next line as well, where we have redeclared the divisor variable. In any case, we can head back to our source file and then comment out this section which is problematic. So once again, we make use of the multi-line comment which is available in JavaScript, and then confirm that the errors have disappeared. So there are no more errors in the console now. And now heading back to the source file, we make use of one more keyword which can be used when declaring variables, and this is the const keyword. You may have guessed that this is used in order to specify constant values, and in JavaScript, const variables can neither be redeclared nor updated. One more thing you might observe is that I have declared this variable my_birthday in all uppercase and using underscores to separate the individual words. So this is a practice which is followed when declaring constant variables in JavaScript. Most programmers use camel case for other variables. So we initialize the value of this const myBirthday to a specific string, and then we print it out to the console. So we can test it out by heading to the browser now, and this variable declaration with const has also worked. Heading back to the source now, let us try to update this const variable. Now anybody's birthday should be a constant value. However, let's see what happens if we do try to update this so that we are 10 years younger. And heading to the browser, when we hit refresh, what we end up with is an uncaught type error. So assigning a value to a constant variable is not permitted. We can only assign a value at the point of declaration, and then beyond that, the value needs to be constant. So we can head back to the source and then remove this particular line and then ensure that the code runs without any errors. And once we do that, let us try to redeclare this variable using the const keyword. So updating the variable was not permitted. However, can we redeclare it so that we can set a new value for my_birthday? Well, we head over to the browser to test it out. And when we hit refresh, we once again end up with an uncaught syntax error. So just as the case with variables declared with let, the const keyword prevents the redeclaration of variables. So we have now covered some of the differences between the variables var, let, and const, and there are a few more as well, which we will take a look at just a little later. Before we proceed, however, we head back to the source code and make sure that there are no more errors which will be thrown. So I'm just going to comment out this particular line and then refresh the page in the browser. And once again, all of the console statements are back. In the previous video, we took a look at some of the differences between variables which are declared using the var, let, and const keywords. We played with those keywords in terms of the redeclaration of those variables and the updating of those variables' values. We will now take a look at another feature which is available in JavaScript, and this is known as variable hoisting. So what exactly is meant by variable hoisting? Well, take a look at these new lines of code. Here, we initialize a variable called a to a value of 5, and we do this before the variable has been declared. We also access the value of a when printing out this message to the console, and then it is after these two uses of the variable that we declare it using the var keyword. So the use of a variable before it is declared is known as variable hoisting. So let's see if this is possible when we declare a variable using the var keyword. So heading over to the browser and then hitting refresh, we see from the bottom of the console.log statements that the value of a is available to us. So variable hoisting is possible when we make use of the var keyword to declare that variable. How about the use of let and const, however? So heading back to our source file, we will now make use of another variable b, where we once again assign it a value and then print it out to the console. And then after that, we declare this variable using the let keyword. So variable hoisting is something which is not possible when the let keyword is used. And to confirm that, we head back to the browser and then hit refresh. And what we get is an uncaught reference error in the line where we assign a value to the variable b. Alright, to get rid of this error, I'm just going to comment out this section of code. And then heading to the browser, I'll just refresh the page in order to eliminate all errors. And now that we have an error-free console, we head back to the source code and then perform variable hoisting for a variable declared using const. So to test this out, we head over to the browser and refresh. And this also throws an uncaught syntax error. So we have explored some of the differences between var, let, and const, and we will continue exploring this later on in this learning path. For now though, we will move along and take a look at some other special keywords which represent non-existent values in JavaScript. These are undefined and null. To demonstrate this though, I have created one more directory within my workspace. And then again, there is an HTML file and a JS file we will use for this demo. So this references an undefined.js source file. And then heading over to that JS file itself, I'll just go ahead and paste the code. So in addition to the use of the use strict directive, I have declared two different variables. The first of these is called uninitialized var, and the second of these is called uninitialized let. You will know the use of the var and let keywords when declaring these variables. So what exactly is the value of a variable if you have declared it, but you haven't really set it a value? This is where a special value which we came across a little earlier on in this learning path enters the picture, and this is the value of undefined. In fact, it is also possible for us to assign a value of undefined to some variables. So we will be setting this value to a variable defined using the var keyword and another one using the let keyword, and we will also print these out to the console. So undefined in JavaScript is used in order to represent a variable whose value has not been set as yet. The variables uninitialized var and uninitialized let are implicitly given a value of undefined, whereas the undefined var and undefined let are explicitly set this value. This is to contrast the undefined value from another special value used in JavaScript to represent a non-existent value, and that is null. Null is a value which needs to be explicitly assigned to a variable, and no variable in JavaScript is implicitly given a value of null. Unlike some other programming languages, JavaScript makes a distinction between these two values which represent empty variables. And this is for developers to know whether a variable has an empty value because it has not been initialized yet or because it has explicitly been set to null. So let's test these out by saving down the source file, heading over to the browser, and then opening up undefined.html. Once the page has been loaded, I'll just bring up the console, and we can see here that the first 4 console.log statements all print out undefined. So variables which have been declared but not initialized are implicitly set a value of undefined. However, it is possible to explicitly assign this value as well. There are many developers, though, who choose not to perform any explicit setting of undefined values and will instead use null in order to distinguish between declared but uninitialized variables and those which have been explicitly set a null value. So these are some of the quirks of JavaScript which those coming in with a background in other languages need to be aware of. And continuing with these quirks, we will now take a look at one more set of operations where the behavior of JavaScript is a little different from that of other programming languages. We have already discussed the fact that JavaScript is a weakly typed language, which means that the types for various variables may be assigned at runtime and could produce unpredictable results. I will demonstrate this by the use of the concatenation operation, and we will see how values are evaluated from left to right in various expressions involving the concatenation of different types. So after creating this HTML and JS file, let us head over to the left-right.js source, which is currently empty. And then I'll go ahead and paste the code. First, we will declare a variable x and then give this a value by performing an operation using the plus operator. So here, we start with the string 5, and to that we add 2 and 3, both of which are numbers. So what exactly will the value of x turn out to be? Well, to get an idea, we need to evaluate the expression to the right of the equals to sign from left to right. Since the first of these values is a string of 5, the operation which will be performed by the plus operator will in fact be a string concatenation. So the first plus operator will concatenate the string 5 to the string 2 after performing an implicit conversion of the number 2 to a string. So at this point, we will end up with the string 52. This in turn needs to be added to the number 3, and once again, an implicit conversion of the number 3 to a string will be performed to give us the string 523. So after that value has been printed to the console, we will redeclare x, and once again, we will assign it a value based on an expression. JavaScript will once again evaluate the expression to the right of the equals to from left to right. So it will observe that the first value here is the number 2 and the second one is the number 3. This is why the first plus operator in this case will in fact perform an addition of two numbers to give the value of 5. When the rest of the expression is evaluated though, there is another implicit conversion which needs to be performed because we will be adding the number 5 to the string 7. So here, the value of 5 will turn into a string, and then we end up with a concatenated string with a value of 57. We will also confirm that when a variable is declared using the let keyword, this behavior is exactly the same. So once again, there will be an implicit conversion of the numbers 2 and 3 to strings to give us a value of 523 in the form of a string. And with the variable z, again, we will end up with a value of 55 within a string. So to confirm this output, we head over to the browser and open up this HTML page. And then from the console, we observe that exactly as expected, the original value of x is 523, the redefined value is 57, whereas y and z are 523 and 55 respectively. JavaScript allows us to define interactive behavior for HTML pages. We have already taken a look at one example of this, where we triggered a window alert when a user clicked on a button earlier on in this learning path. We will now take a look at the window alert once more and also examine the prompt and confirm functions available in JavaScript in order to obtain information from the user while conveying some details to them. So for this demo, we once again have an HTML and JS file, and this is the HTML. And moving along to the JavaScript, we once again make use of the use strict directive, and then we invoke the alert function in order to bring up an alert window. We have already taken a look at this previously, and this is used in order to convey some information to the user. So when invoking an alert, the communication is unidirectional. That is from the application to the user. There is no way for the user to communicate any information, and all they can do is close down the alert window. So let us see how this works by saving down this file and then bringing up the page in the browser. And sure enough, the alert window pops up, and you can see here that there is just one option for the user, which is to click OK, which will close down the alert window. One thing you may notice is that this alert window has popped up before the HTML page has been loaded into the browser. So let's see what happens when you hit OK. Well, this is where the loading of the page does complete, and we see the HTML rendered here. Now when we bring up the console, we see nothing at all because we haven't invoked console.log in our code just yet. Moving back to the source now, and after the alert has been dismissed, we will bring up one more window in order to convey some information to the user. But this time we will also accept some input from them. So to do this, we need to create a prompt. So we invoke the prompt function for this, and this is where we convey the message asking the user to input a value. A prompt window will include a field in which a user can enter this value, and that value will be assigned to the variable name. To confirm that the value input by the user is assigned to this variable, we will print out its value to the console. So once a user has given us their name via this prompt message, we will give them another prompt, and this is where we ask them to give us the name of a subject or a course. This time though, the arguments to the prompt function include not just one string, but two. And the second string in fact represents the default value for the user input. So in this way, the user can stick with this default value or override it by setting one of their own. So we now have two prompt messages defined, one of which does not have a default value and the other one which does. Both of these will be used to gather input from the user, and then we assign it to variables whose value will be printed to the console. In JavaScript, it is possible for us to interact with the user by using both prompts and alerts. So here we accept some input from the user by means of a prompt where we ask them to enter a number for which we will calculate and then return a square value. The input value is assigned to the variable a. We then calculate b as the square of a, and then we return both the original as well as the square value through an alert window. So let's see exactly how this works by saving down our source, heading back to the browser, and then refreshing the page. So before the HTML gets to load in the browser, we see the first alert message, and we dismiss this by hitting OK. And this brings up the first of the prompts. So we see the prompt message exactly as we had defined it within our source file, and this is followed by a text field which is blank. It is blank because we did not specify any default value. So we can now supply such a value. So I'm just going to enter the name John, and you could either click OK or even hit the enter button. And then following that, the second of our prompts shows up. Before we get to that, however, you'll observe in the console that the value which was entered by the user has been assigned to the variable, and that has been printed out to the console. Moving along now to the second prompt, not only do we have the prompt message, but the default value of JavaScript which we had set for it also shows up in the text field. On this occasion, we will stick with the default value and then just hit OK. And this brings up the third prompt. Again, you'll observe in the console that the value of JavaScript has been assigned to the variable and printed out. Moving on to the new prompt message though, this is where we are asked to enter a numeric value for which the square will be calculated and returned. So I'll just enter the value of 4. And after that, this new alert window pops up, which shows us that the value of 4 has a square of 16. We can now see what happens if we pass along blank values for the prompt messages. So we reload the page and then dismiss the first of these alerts. And then when prompted to enter a name, I'll go ahead and click cancel. You'll observe in the console that the value returned by the prompt function in this case was in fact null. So we turn our attention to this second prompt, which has the default value of JavaScript in the text field. And when we hit cancel this time, again a value of null shows up. For this third prompt, I'll once again hit cancel. And we observe that again a null was passed in, but the square of null has been calculated as 0. We will dismiss this and then perform some more tests by first refreshing the page. I'll just dismiss this alert. And then at this prompt message, I will just hit OK without passing in any value. And you'll observe that the value which has been passed along is in fact a blank string, which is why in the console, you see nothing after the text you have entered. So sticking with the default value for the second prompt, we again see JavaScript getting printed to the console. And when prompted for a number, I will again leave the space blank and hit OK. And you'll see that once again it is a blank value which has been passed in, and the square of that has been calculated as 0. So now that we have some familiarity with prompts and alerts, we can dismiss this alert and then head back to the source code, where we'll play around with one more type of window which can show up, and this is a confirm message. This is where a window will appear along with some text, and then this will be followed by two buttons, OK and cancel. So we invoke the confirm function along with a confirmation message where we ask the user whether they are ready to move on to the next demo. Whether they hit OK or cancel, what will be returned is a Boolean value, and then we evaluate this Boolean value using an if statement. For this, we make use of the if keyword followed by parentheses, where we have the expression whose value needs to be evaluated. So if the user hit the OK button, then the value of this output variable will be true, in which case we print out to the console that the user has hit OK. If the user hits the cancel button, then the value of output will be false, in which case the code execution will move to the else block, where we'll print out to the console that the user has hit cancel. It's time to test this out now. So we head over to the browser and refresh. And I'll quickly dismiss all of the alerts and prompts which we still have in our code. And following that, when the confirm message shows up, this time I will hit OK, which means that the condition in our if statement evaluates to true, and then the message which is printed to the console is that the user has hit OK. We will ensure that hitting the cancel button works as expected. So I'll just refresh the page once more and then dismiss all of these alerts and prompts. And then again, when the confirmation message shows up, this time we hit cancel. And the message in the console confirms that the code execution did in fact move into the else block of our if-else statement. So we now know how to interact with the users of our web pages by means of alerts, prompts, and confirms. This course involved taking the first steps into the world of JavaScript programming. We began by implementing a Hello World app in JavaScript and looked into the linking of HTML files to JavaScript code. First, by including JavaScript code inside an HTML file and then separating the two. We then examined variable declarations in JavaScript, including the use of var, let, and const, as well as the effect of strict mode on your code. Finally, we explored the use of alerts, prompts, and confirm messages for your app in order to interact with its end users. At this point, you have tested the waters when it comes to JavaScript development, and you can move on to a course where you are exposed to some more features of the language. These include types, such as numbers and strings, arithmetic and logical operators, as well as control structures such as if-else blocks and for loops.